Number 12, we're given a diagram here with a box and a force, angled force. We're told that the box just starts to move. So keyword right here, just starts to move, implies impending motion. And at impending motion, we know that the friction force is mu sub s times n. So important point there. We want to determine mu sub s, the static coefficient of friction. Okay, so we are required to need a free body diagram, so let's draw that real quickly here. There's our box, here's our forces, weight, normal force, angled force, 20 degrees. Okay, and friction is going to be opposing that. Okay, so, and we'll use x and y. So we know the sum of the forces in x is equal to 0 at impending motion. So we can write that equation. 40, this horizontal component is going to be cosine 20. That's going to be to the right, so that's positive, minus friction force is going to be equal to 0. And again, the friction force, we're going to use that equation right there. We know sum of forces in the y are also equal to 0. Okay, be careful, the normal is not the weight because we have an extra force going down there. So we'll have a minus 40 sine 20. This downward component, okay, opposite the 20-degree angle, the downward is the minus, okay, minus the weight plus the normal force is equal to 0. Okay, so we can solve for the normal force right here. Let's see, it looks like it's going to be 40 sine 20 plus 60. 73.68 units of pounds. So we'll bring this equation down and say 40 cosine 20 minus mu sub s times 73.68 equals 0 mu sub s. Okay, so it's going to be 40 cosine 20 divided by our previous answer, 73.68. Oops. Divided by that. So 0.51. 0. Static coefficient or coefficients of friction are unitless. Okay, because they just relate to forces here. And so there's our final answer.